program ever used an app that suddenly crashes? Well, today I'll show you the types of testing in SQA that prevent that from happening. Let's jump in. The first type is functional testing. In this case, we must ensure it works as per the requirements. Functional testing is like the police enforcing the law. Just as police check whether people follow rules and regulations, functional testing checks whether software behaves according to its specified requirements, right? Simply remember, it is like a law enforcement and it ensures the system follows the defined rules, right? The next one is the unit testing. In this case, individual components or units of code are tested in isolation. What are the purposes of this? Verify the correctness of small pieces of code and identify bugs early in the development cycle. Ensure each unit functions as expected, right? In this case, this is testing what the code does. Think about your campus batch. You evaluate each associate one-on-one to see who performs best. Similarly, unit testing checks each component individually to ensure it works correctly. Consider this code. Now, what is unit testing? We test each elements separately. First, we check p tags, right? This one. Secondly, this one, this one, this one. You should check one by one, right? This, finally you can check div tag, right? What are the benefits of unit testing? First one, early bug detection. Identifies issues at the earliest stage of development, right? Second one, improved code quality. Encourages writing modular and maintainable code, right? Next one, fast debugging. It isolates failures to specific units, making debugging easier, right? Next one, documentation. It acts as live documentation for how the code is supposed to work, right? Next benefit is refactoring confidence. Ensures changes don't break existing functionality, right? Next type, integration testing. If we test everything together, p tag, div tag, lead tag, right? That becomes integration testing, not unit testing, right? Consider all of these. Now we check all together, right? That's why it called as integration testing, right? In this case, individual modules or components are combined and tested as a group, right? you know, do mean it's a group, right? Okay, what are the purposes? Verify the interaction between integrated units and ensure combined components work together as expected, right? And detect issues in data flow, communication and interfaces, right? This focuses on testing how the modules work together. Next type, system testing. It means testing the whole system together, right? After all parts are built and connected, we check, does everything work properly as a complete system? And does it meet all requirements? Okay, simply we can say system testing checks whether the entire software works correctly as a whole, right? What are the purposes of this? It makes sure the system does what it's supposed to do, and it checks real world behavior, and it confirms both functional and non-functional requirements. Functional features work, right? Non-functional speed, performance and etc., right? For an example, think about an online shopping app. In system testing, you test the full flow: login, search product, add to cart, payment, order confirmation, right? If all steps work together correctly, system test passes, right? Okay, the next one is acceptance testing. It means checking if the system is ready for the user, right? It's the final testing step before releasing the software, right? What are the purposes of this? Is the system ready to launch? Does it satisfy users? Does it meet business needs? For an example, think about a food delivery app. In acceptance testing, the customer or user checks, can I order food easily? Does payment work? Do I get confirmation? If the user is happy, it is accepted, right? If it is not, need changes, right? It's like a customer checking the product before buying. If it meets their expectations, they accept it, right? The next type, user acceptance testing, right? UAT is when real users test the system before it goes live, right? They check, does it work for me? Is it easy to use? Likewise, right? UAT is testing done by users to see if the system meets their needs, right? What are the purposes of this? Make sure users are satisfied and check if it's user friendly. Confirm it's ready to launch, right? Example, think about a university system. Students test, can I register course? Can I see my result? Is it easy to use? If students are happy, system approved. If confused or errors, fix needed, right? It's like students trying a system and deciding whether it's easy and useful for them. Okay, just try real-life actions like login, submit, etc. Check usability, easy or confusing. Verify functions work properly, right? The next testing type is alpha and beta testing. First, alpha testing, right? It is done by internal teams such as developers, QAs, right? It happens in a controlled environment like a lab, right? We test it ourselves before giving it to users, right? What about beta testing? Beta testing is done by real users, right? It happens in the real world, like actual environment, right? We give it to users to see how it works on real life. These are the differences between them, right? What are the advantages of alpha testing? Finds bugs early, safe testing environment, quick internal feedback, right? What about beta testing? The advantages of beta testing, right? Real user feedback, works in real conditions, and ensures user satisfaction, right? Example, for the alpha, game company tests the game internally. What about beta? Game is given to players to try and give feedback, right? The next type, regression testing. Regression testing means checking if everything still works after changes, right? Regression testing check whether old features still work after new changes, right? Example, think about an app. You fix a login bug, then you test login works, but also check sign up still works, dashboard still loads. If something else breaks, that is the problem, right? What are the purposes of regression testing? It makes sure new changes don't break old features and keep the system stable and maintain software quality. Why it's important? Prevents new bugs, keeps system reliable, saves time and cost, builds confidence, right? When to do it? After bug fixes, after new features, after system or coding changes, after performance improvements, right? It's like fixing one part of your bike and then checking if the whole bike still works properly, right? Okay. The next one is smoking testing. It means doing a quick check to see if the system basically works, right? Smoke testing checks if the main features are working before detailed testing, right? For an example, think about an app after new update. You quickly check app opens, login works, main page loads, right? If these fails, no need to test further. If they pass, continue testing, right? What are the purposes of this? Check basic functions work, see if the build is stable, decide whether to continue testing. Why it is important? Find big problems early, save time, gives quick feedback, avoids testing a broken build, right? It's like a turning on a vehicle to see if it starts before driving it, right? The next one, black box testing. You don't see the code inside, right? You only test inputs and outputs. It checks what the system does. Next type, white box testing, right? In this case, you can see the code inside and you test the logic and structure. It checks how the system works. These are the differences between them, right? What are the purposes of black box? It checks features work correctly and match user requirements. What are the purposes of white box? Check code logic and ensures no errors in structure, right? What about manual testing? It means testing the software by hand without using tools, right? Simply remember, manual testing is when a human tests the system by using it like a real user, right? For an example, think about an app. A tester opens the app, clicks buttons, fills forms and checks results. All done by manually, no automation tools, right? What are the purposes of this? Check if features work correctly, find bugs, and ensure it's user friendly, right? Why it's important? Humans can think and explore, find unexpected issues, right? Checks user experience and useful in early stages, right? Remember, manual testing is like a person using an app and checking everything step by step, just like a real user, right? Next one, automated testing. Automated testing means using tools and scripts to test the software automatically, right? Simply remember this definition. Automated testing is when tests are run by tools instead of humans, right? For an example, think about an app. Instead of a person clicking, a script automatically opens the app, logs in, checks results, right? All done by code automatically, right? What are the purposes of this? Save time, reduce manual work, run tests quickly, improve accuracy. Why it's important? Great for repeating tests, right? And very fast. It works in CI/CD auto testing after every update, right? It can test heavy load of performance. Automated testing is like setting a machine to check everything automatically instead of doing it by hand, right? What are the challenges? Needs coding skills, setup cost, scripts need updates, right? Next type, non-functional testing. It checks how well the system works. Non-functional testing tests the quality of the system, not the features, right? Think about an app. Functional testing asks, does login work? But non-functional testing asks, is login fast? Is it easy to use? Is it secure? Right? What are the purposes of this? Check performance like is speed, right? Check usability like is your heart. Check reliability, stable or crashes. Check security. Alright? It's like not just checking if a car runs, but how fast, smooth and safe it is, right? This is not what the system does, but how well it does it, right? These are the types of non-functional testing, right? The first non-functional testing is performance testing. It checks how fast and stable the system is. Performance testing has several types of testing, right? First one, load testing. Load testing. It checks how the system behaves under normal user load, right? Remember simply, load testing check if the system can handle expected users without slowing down or crashing, right? For an example, think about a website. You simulate 1,000 users using the site at the same time. Then check, is it fast? Does it slow down? Does it crash? Right? What are the purposes of this? Check system speed, ensure stability, find performance problems, right? It's like checking if a classroom can handle 100 students at the same time without chaos, right? The next one, stress testing. It means pushing the system beyond its limits to see when it breaks, right? Remember this simple definition. Stress testing checks how the system behaves under extreme conditions, right? For an example, think about a website, right? You increase users, 1,000 users, okay, but 5,000 users slow, 10,000 users crashes, right? This tells you the break point. What are the purposes of this? Find system limits, see when it crashes, check recovery after failure, right? It's like overloading a bus with too many passengers to see when it can't handle anymore, right? Okay. The next testing type is endurance testing. It means checking if the system works well over a long time, right? Remember like this. Endurance testing checks if the system stays stable during long usage, right? For an example, think about a system. You run it with normal users for 24 hours, right? Then check, does it slow down? Does it crash? Any memory issue, right? What are the purposes of this? Check long-term stability, find memory leaks, and detect performance drop. Next type, spike testing. Spike testing is checking how the system reacts to sudden increases in users, right? Spike testing checks what happens when traffic suddenly jumps up or down, right? Think about a website. Suddenly, users go from 100 to 10,000 instantly, right? Then checks, does it crash? Does it slow down? Can it recover quickly, right? What are the purposes of this? Test sudden traffic changes and check system stability and see recovery behavior, right? It's like a shop suddenly getting a huge crowd at once and seeing if it can handle it, right? Okay. If you get something from this video, don't forget to subscribe us, right? Let's resume next part with next video, right? Bye bye.